All right, what do we have today? We have differential equations day 1. Okay, so we have looked at differential, we've taken the derivative, so differential is the same root word as derivative. Okay, and there are 2 ways that we can do this. Let's see. We have y prime, okay, and we have y double prime, so we've been taking derivatives and things all over the place. Okay, so what we're going to do is use this process called separation of variables, a strategy that you use to get your dependent variables on one side and your independent variables on the other side. Okay, because we can only solve for one equation at a time, and traditionally we like to have y equals is equations, or p equals, or n equals. So separation of variables is the algebraic strategy that we're going to use in the first step of solving this equation. Okay, so notice here we have a differential equation, dy dx, right? This is also known as y prime or f prime, right? This is the derivative of our function with respect to x, equals this ratio of 2x divided by y. Okay, so what we want to do is we want to get all the y stuff on the left side, and we want to get the x stuff on the right side. Okay, so separating means we need to take this y value here in the denominator and move it to this side. And we move a denominator by multiplying. So now we have something that looks like y dy, right? y times dy divided by dx equals 2x. And now we're going to take this dx, we're going to multiply both sides by dx, and we have our equations y times dy equals 2x dx. So no longer do we have fractions, we have all of our y stuff on the left side, and we have all of our x stuff on the right side. Okay, so we've learned how do we solve a differential equation. How do we undifferentiate something? We take its antiderivative by doing the integral, right? This is the mathematical symbol which says take the antiderivative. So now we have to integrate both sides. What we do to one side, we have to do to the other to stay mathematically legal. Okay, it has to be a balanced equation. So if we integrate the left, then we have to integrate the right. Okay, what is the antiderivative of y? Use our rules. What's the antiderivative of y? Y squared over 2. Okay, our rule of antiderivatives is we add 1 to the power. So this is y to the first power. Even though we don't ever write a y to the first power, that's y to the first power, so we add 1, so we get y squared, and then we divide by 2, right? Multiply by the reciprocal of 2, which is 1/2. So the derivative on the left is y squared over 2. Equals, what is the antiderivative of 2x? That's right, 2x squared also divided by 2, but the 2 and the 2 divide each other out. So it's just x squared. Now, anytime we take an antiderivative, we're always going to have this constant of variation, right? This plus c. So every time we take an antiderivative, right, and we're not trying to evaluate it from a lower bound to an upper bound, then we're going to have this c value hanging out right there. Okay? So this is the point, right? We have not quite done it. We've done our antiderivatives. Now we have to get y by itself. Okay, so what's our next algebraic step in getting y by itself? Multiply everything by 2. Multiply everything by 2. So this just becomes y squared, and over here, 2x squared plus, really we have 2c, right? We're multiplying our c value by 2. We don't know what our c value is. And really, in mathematics, we can literally just call this some other c value. All right, well, let's call this c sub 2, right? Some other c value that is something we started with times 2. Okay, so we can leave it like that. In fact, we don't even really need that subscript. Some other c, right? Some other random c. But let's put this subscript back in just to be true. And then our last step to solving this for y is to take the square root. So we're going to square root everything, right? When we square root something, we do it once to the left side and once to the right side. So y equals the square root of 2x squared plus some c value. Okay, and that's our equation solved for y. Very good algebraic job. So now it says this is called the general solution, right? So we're going to now find the particular solution if we know where our function starts, or if we know that we have a point. We have this point that when x is 1, y is negative 3. Okay, what if you were given this initial condition? So these are your words you're looking for. Initial condition that y of 1 equals negative 3. Okay, so our x value is 1 and our y value is negative 3. And we're going to go into this part of our equation. Okay, we're going to go into this, because this is where we first introduce our c value. We're not going to plug it into our final equation. Go back into where we first introduced our c. Y squared over 2 equals x squared plus c. Okay, that's where we're going to start. So let's replace our x value. Positive 1 is your x value, and negative 3 is our y value. So we replace y with negative 3, and we replace x with 1. All right, so now our only variable is c, and we can do the algebra to solve for c. What is negative 3 squared? Positive 9. 9 divided by 2 is, well, that's just 9/2. 1 squared is 1 plus c. So now we have to subtract 1 from both sides. And what does our c value end up becoming? 7 over 2. Right, because we're going to change our 1 to be a fraction, 2 over 2. So 9 over 2 minus 2 over 2 is 7 over 2. Okay, so that goes into our equation right here. Right there. So y squared over 2 equals x squared plus 7 over 2. So when we solve this equation for y, doing the same steps that we did up above, we get the final equation, y equals the square root of 2x squared plus 7. Okay, let's look at our second example. Y prime equals x squared times the square root of y, and this is your initial condition. Okay, that's going to help us find our particular solution once we take the antiderivative, help us solve for c. Right, this is going to help us solve for c. So let's first rewrite y prime. We can rewrite y prime as dy over dx. Okay, we're going to separate our variables. First, we're going to multiply both sides by dx. And we're going to divide both sides by the square root of y. Okay, because this is x squared times the square root of y. So we divide both sides by the square root of y. So our equation looks like dy over root y equals x squared dx. Okay, now we do our calculus step we take the integral of both sides. So before I do this, we're going to do some simplifying. Okay, so we have to remember some things about the square roots. Okay, either you can memorize what happens when you take a square root's antiderivative, or we can do this every time. So the square root is also known as the 1/2 power. Right? Our basic rule of antiderivatives is the power rule. So we change our square roots to be y to the 1/2. Well, since our square root is in the denominator, this is actually y to the negative 1/2 power. Okay, so we are just rearranging our dy over root y so that we have y to the negative 1/2. Okay, the square root is the 1/2 power, and because it's in the denominator, that means it's a negative power.
So that's the same thing.
These are the same thing. This is wearing a dress like it wants to go to church on Sunday morning. This is going to the pool on Friday afternoon. Same math equation, just looks different. Okay, so what is the antiderivative of y to the negative 1/2? Let's add 1 to the power. What's negative 1/2 plus 1? That's positive 1/2. And then multiply by the reciprocal of 1/2, which is 2. So the antiderivative of 1 over root y is 2y to the 1/2. Equals, what's the antiderivative of x squared? X cubed over 3, and then we have our plus c, our plus constant of integration. Okay, now we're going to plug in our y and your x. So we have 2 times 4 to the 1/2 power equals 3. All right, 3 is your x value, 3 cubed divided by 3. Remember, when we simplify this, the 1/2 power is the same as the square root. So we take the square root of 4. The square root of 4 is 2. 2 times 2 is 4. 3 cubed. 3 times 3 times 3 is 27. 27 divided by 3 is 9. So when we subtract 9 from both sides, c is negative 5. Okay? So we're going to go back into this equation. 2 times the square root of y equals x cubed over 3 minus 5. Okay, now that we've solved for c, we're going to plug it back into our antiderivation, right? Our integral when we've integrated. And we're going to solve this back for y. Okay, let's solve this for y. Okay, for an FRQ, you don't have to simplify this problem. Okay, but we do have to do all of the math. So our first math would be divide by 2. Okay, so there's lots of ways that you can write divided by 2. You can literally do that whole entire thing divided by 2. And you can leave it just like that. That is fine. Okay, we could, if you wanted to, change this to x cubed over 6 minus 5 over 2, right? Which is what it would be if we actually divided this term by 2, the denominator doubles, and divided that term. But you don't have to for AP Calculus. So you don't have to. So the square root of y, we could also write it as 1/2 in front. There's lots of ways that we could write this that are all correct. Okay, all of these are correct. You could leave it like this, or you could write it with the 1/2 in front. It doesn't matter. But our last step is to square both sides. Now we square one thing, so it matters where we put parentheses. Okay, so you have to put parentheses in the correct places. So this would be 1/2 of x cubed over 3 minus 5 squared, right? That's one way that you could write this. We could have done this up here and squared it. That's also correct. We could have done this and squared it. That's also correct. There are lots of ways that you can write your answer. Calculus doesn't care. But if you go to simplify it and you simplify wrong, then you get it wrong. So when in doubt, don't simplify it out. Okay, there's one more differential equation example. Let me go to that right now. Okay, here's our initial condition that we're going to use to find your C value. Okay, we always use your initial condition to find that constant of integration. Okay, separate our variables. We're going to multiply both sides by dx. Right, that moves it over here. And we're going to divide both sides by y squared. Okay, so when in doubt, leave the number, if we can, with your x. Okay, don't bring the number over with the y. Leave the number on the x side. Try to only move the y stuff if possible. So dy over y squared equals 4x dx. And our next step is the calculus, and that is to take the integral of both sides. Okay, so once again, we're going to rearrange our left side. If we have 1 over y squared, that's the same as y to the negative 2 power. Okay, our one antiderivative rule, if it's not of special form, is to make it into a power. So y squared in the denominator becomes y to the negative 2 power. Okay, so now let's use our rule. Add 1. What's negative 2 plus 1? Negative 1. And divide by negative 1 means that our antiderivative is negative y to the negative 1 power. Okay, how else can we write y to the negative 1 power to make it simpler? Put it back in your denominator. Okay, so the antiderivative of dy over y squared is negative 1 over y. Okay, and that equals, what's the antiderivative of 4x? Yep, 4x squared divided by 2, which simplifies to 2x squared plus c. Okay, so this is the equation that we're going to use to solve for c. Okay, let's solve this for c. So this is negative 1 over 3 equals 2 times 1 squared plus c. 2 times 1 squared, well, that's just 2. So I need to subtract 2 from both sides, and c equals negative 2 and 1/3. Negative 2 and 1/3. So now I'm going to come back into here and make that into negative 2 and 1/3. 2x squared minus 2 and 1/3. So to solve this for y, let's first multiply by negative 1. Okay, let's change all these things, change the signs. So 1 over y equals negative 2x squared plus 2 and 1/3. Okay, now we'll multiply both sides by y. So all of this goes in parentheses and y goes on the outside. Negative 2x squared plus 2 and 1/3 times y. So we're going to divide both sides by everything in parentheses. So y equals 1 over negative 2x squared plus 2 and 1/3. That's our final answer, right? We don't have to simplify that. We can leave it just like that. Okay, perfect. Some differential equation solving use the initial condition to find the C value, and then do the algebra to solve for y. Oh, there's the bell. Good timing. Have a swell day.